huge asset to, I guess, the pro football team. So here's my best friend, Craig.
So, just a disclaimer before I start. This isn't going to be a normal speech. I'm going to cover a lot of material, so I'm going to talk pretty fast. My slideshow is really important, so look up there and not down here. And finally, I can only demand that you sit in your seat, but I ask for 3 things. Keep your eyes open, your ears open, and your mind open. So, let's start. Perhaps you've heard that I'm doing my speech on everything. Well, I am. Here's a brief conversation with my grandma that really inspired me. What are you doing your speech on, Craig? Well, everything, Grandma. How are you going to do it on everything? Where are you going to start? At the beginning. The beginning? Yeah, of everything. Whatever, honey. Perhaps now is the time for a definition. Everything. Noun. All that exists. All that is important. There you go. Concise, precise, and impressively vague. And here's where I hit my first roadblock. How am I going to talk about everything? Well, good thing I have Grandma. We'll take her advice and start at the beginning of it all. I believe it's called the Big Bang. Cynically summarized, first there was nothing, and then it exploded. Then there was everything. More specifically, the Big Bang is the direct conversion of energy into matter, initially quarks, gluons, and the like. All this post-explosion matter quickly dissipated enough energy to congeal to the basic parts of the atom that we're familiar with today. I assume you've all heard of the creation of everything, and if not, I encourage you to look it up. It's pretty cool stuff. Anyways, the everything that was created consisted entirely of hydrogen once the universe reached the ripe old age of 1 second. Well, if only hydrogen was created, where did all the other elements come from? Let me answer the question I just put in your mouth. Stars. I'll pose a question. If stars created the elements, what created stars? If everything exploded at the beginning of time, how do little things such as stars and planets form? Well, the way I understand things, explosions typically don't cause things to come together. Well, this is part of what makes the Big Bang so cool. It's the sheer amount of matter involved. When the Big Bang, well, banged, enormous quantities of hydrogen radiated outward in a general sphere. Particularly dense patches of mass actually generated their own gravity, collecting other nearby clumps of matter, forming a nebula. Once a certain critical mass is reached, the matter collapses in on itself, increasing both the heat and pressure until a nuclear fusion reaction begins. The furnace of a star is the only thing powerful enough to sustain a nuclear fusion reaction. Basically, the heat and pressure generated by the star are actually enough to force a proton and electron together, creating a neutron and a vast amount of energy in the process. This process actually forces the newly created neutrons and protons together to form helium from hydrogen and so on, continuing down the periodic table until you get to iron, the 26th element. Iron does a boot in the reaction because it's the point of diminishing returns. It takes more energy to create iron than is released by the reaction. And it's important to note here that as a star creates each new element, the star begins to burn it for fuel in the reaction. Since iron has the most stable nucleus of all the elements, the stars can't generate enough energy to continue the reaction, which causes the reaction to come to a lumbering halt. So here's a general picture of the life cycle of a star. This here is our sun. This is once a star begins to burn helium, and this star is burning pretty heavy elements. And you might be wondering now, there are a lot of elements heavier than iron. Where did they come from? Well, this is a star burning iron. Well, technically it's not burning iron, it's actually gone supernova, or in layman's terms, exploded. The only thing possibly powerful enough to lose energy on a reaction of this scale is a star going supernova. Well, now, time for something completely different. Life. How did it start? I'll start with the theory most widely accepted in the scientific world. After approximately 3.6 billion years, early Earth had finally gathered enough of the compounds necessary for life for something miraculous to happen. Basically, almost the entire early Earth was covered in a thick gruel consisting of all the ingredients necessary for life. The Earth chilled, freezing said gruel into a massive snow cone. And this is extraordinarily important because only the water froze, creating countless pockets containing high concentrations of the building blocks of life. Basically, you have a pocket, frozen of course, into which you put the elements of life, apply pressure, and then repeat. The pressure is key because normally the low temperatures would keep anything from happening, but with pressure, the compounds in the pockets combine in all sorts of ways. The odds of their combining into life are infinitesimally small, almost impossible, but remember that had occurred in trillions of tiny pockets all over the Earth, over the course of millions of years. So, given essentially infinite time and places to occur, nearly impossible is guaranteed to happen. So, happened it did, yielding us our first life, which was probably a virus. What followed was only the natural course of events, the seeking of the most efficient way to survive and reproduce. Bacteria soon evolved, and following that, simple single-celled photosynthetic organisms, and from these humble beginnings, life began to colonize the slowly falling planet, filling every niche imaginable, and eventually leading to life as we know it. Nothing really fantastic happens until the Permian era, which is the point in Earth's history when life exited the ocean and conquered the land. The first of the fish to exit the safety of the ocean became four-legged reptiles and amphibians. There were so many new niches for the rising reptiles that conquered our land, and so much open space in the ocean that the number of species boomed. In fact, the Permian was the point in Earth's history that had the greatest biodiversity and the highest biomass of any point in Earth's history. To help you comprehend the magnitude of the Permian explosion, think of the history of the Earth as a book with 902 pages. The first 814 pages are blank. Page 815. The first page of the Permian has detailed, full-color illustrations of over 50 phyla animals, only 35 of which exist today. You might be wondering what happened to this magnificent abundance of life, and I'll tell you, the Permian explosion. This extinction represents the largest single die-off of life in Earth's history. Somewhere along the lines of 60% of all marine species disappeared, and 70% of all terrestrial species disappeared. Even insects, the things that can survive a nuclear explosion, died off. In fact, this is the only extinction that has ever affected insects. After this enormous event, 99.5% of individual animals died. To grasp that, think about this. Everyone in this room represents the pre-extinction population, and after the extinction, only one of us is left alive. I'm not going to lie to you here. It absolutely staggers me that life managed to persist through this catastrophic event. In fact, not only persist, but flourish. And now might be a good time to orient you in Earth's history. Here is a fantastic diagram to help you follow where we are. This is a confusing and hard-to-read chart showing the various periods in Earth's history. I'm going to make this simpler. Beginning is nothing. Next is basically nothing, and after that is practically nothing. Next is the Permian era that you've heard so much about, and shortly thereafter is the age of dinosaurs. And after those pea brains came everything that we're familiar with, and then of course, us. And these two little pink bars represent everything that we're familiar with. The two largest mass extinctions. Back to that extinction that almost wiped the face of the planet clean. I'm pretty sure you noticed there's a lot of life going on after it. Even another extinction. The age of dinosaurs immediately followed the Permian extinction, and obviously the diversity of life was much lower, as well as the biomass, but both of those began to grow again. Unfortunately, the levels seen in the Permian era were never again reached. But two things the Permian era didn't have that the age of dinosaurs did were mammals and birds. These two new classes of life began to spread around the planet, filling niches and evolving. The dinosaurs were prominent until the end of the Cretaceous, most likely triggered by a meteor strike on an apocalyptic scale, and Ice Age rapidly settled over the planet. This is good because dinosaurs are bad for our health, and basically once the Ice Age settled in over the planet, all the dinosaurs that walked on land died. Their bodies were simply too large to warm up. This is great for early mammals because it allowed them to take their place as the dominant form of life on the planet. So, there you have it. The absence of the top predators led to the rise of mammals. They increased in complexity and intelligence, beginning with what is basically a shrew, and eventually led to the development of primates. So, looking back now at how we started, it's absolutely dumbfounding to see how far we've come. What astonishes me is how far we still have to go. More on that in a minute, but for now, consider this. The length of the DNA contained in each of your cells is more than 6.5 feet long. We share 99% of the information contained within these strands with pigs and 99.5% with apes. Most of the differences caused by that 0.5% manifests itself in our brains. Our brains are an amazing piece of hardware, capable of 100 million instructions per second. You might think that our supercomputers must be many times more powerful than our own brains, but in fact, they've only just reached the intelligence of a kitten. In fact, our brains are so amazing that the internet, the entire thing, all of the data stored on the entire internet could be stored on 4 humans' brains. Want to know something truly amazing? We only use about 10% of our brain's potential. 10% of our brains has gotten us this far. It's hard to comprehend what we could do if we could use all of our brains. Well, here's a little example related to unused potential. A gallon of gas. Yes, the same stuff you put in your car. We use such a tiny fraction of its energy that if we could harness all the energy stored in a single gallon of gas, we could send a man to the moon and back. The moon. on 1 gallon of gas. Look how far we've come with what we have, and just think how far we could go with what we have. Now, on to the point. Perhaps of everything. I'd like you to remember not necessarily my speech, but at least what it was about next time you're feeling down. I want you to think back to the beginning of everything, how everything happened in just the right ways to make life happen. The extraordinary hardships that life endured, the recovery, the evolution, the advancement of intelligence. Well, I think Lawrence Krauss said it best. Every atom in your body came from a star that exploded, and the atoms in your left hand probably came from a different star than those in your right hand. It's really the most poetic thing I know about physics. You're all stardust. You couldn't be here if the stars hadn't exploded because the elements, the carbon, nitrogen, oxygen, iron, all the things that matter for evolution and for life, weren't created at the beginning of time. They were created in the nuclear furnace of stars. And the only way for them to get into your body is if those stars were kind enough to explode. The stars died so that you could be here today. I want you to think on that. Every single one of us is a huge collection of miracles. Thank you.